Let me continue with our previous discussion on interference of light by focusing more on the concept and their mathematical equations. In this representation, when a wave is traveling in the space, when the wave is propagating in the space, we represent that propagation of wave in space usually by this geometrical representation. It is a line with crest and trough. I mean, a line with a series of crest and series of troughs like this. That is a representation. In this wave representation, after the propagation of light in the space, the distance traveled by the wave, what the distance traveled by the wave in the space can be represented by two terms in this case. One is path, other is phase. What is the difference between the term path and phase? Path is the linear displacement. The linear displacement of the wave along the x-axis. The unit is meter, of course, in SI unit. What is phase? Phase is the angular displacement. Here, angular displacement along the y-axis with respect to x. Here, angular displacement. Here, disturbing away from this equilibrium, from this equilibrium, and like this. Angular displacement. This displacement of wave from this point to this point, it is represented as lambda, the path lambda. In terms of phase, the distance between this point and this point in terms of angular displacement, 2 pi. Here linear displacements in meter, of course, from here to here. What is 2 pi? Since the point is moving along this smooth line like this. While the point is moving along this, the angle changes. Every point on this line can be expressed as angle in radians. From 0, some radians, increase the radians. Here pi by 2 is the radians. The value of angle is pi by 2 in radians. And further increase like this becomes pi. So the value of radians, that is angle increasing from here to here, that is 0 to pi radians, and further it increases from here to here, but in the opposite direction. But is one more phi like this. Total distance covered from this point to this point in terms of angle is 2 pi. Therefore, the distance between this point and this point, starting point is this point is 2 pi, the angular displacement. And from this point to this point is linear displacement lambda. This is known as one wave or one unit of the wave. The distance or the length is lambda. It is called as wavelength of the wave. 2 pi is the 2 pi corresponds to 2 pi, the angular displacement. Lambda equals 2 pi for one wave. Lambda equals 2 pi for one wave. Or we can write like this also, lambda by 2 equals pi like this. In this wave representation, The propagation of wave along the x-axis is seen as multiple of this unit, that is wave, one cycle or one wave. So that one wave and further traveling like this, another wave, one more wave like this. If that is the case, the total distance traveled by the wave along the axis, x-axis, is or can be represented as multiple of this length, that is n lambda or n into 2 pi. What is the value of n? 0, 1, 2, 3 or 1000 or what is that? Infinite number. The total distance traveled by the wave can be either represented as n lambda or n into 2 pi, where n is a natural number like this. Multiple. N lambda says distance, linear distance. Here n 2 pi says angular displacement. Both are same in terms of angle, in terms of linear distance. Now this is regarding one wave. If there are two waves like this along the x-axis or in different directions, doesn't matter. Here, this is one wave traveling in this, that is another wave is traveling with this. And we can write the equation, the sinusoidal equation for each wave, the wave function. That is 1 to y1 equals this, y2 equals this. And these have, there is a difference between these two waves. The difference we speak either in terms of the phase difference or path difference. Here I said, if you use phase, becomes phase difference. If you use path, becomes path difference. But whatever the value inside the sign of this is always phase. It is already, or you can write either y1 equals like this, y2 is like this. Here phase difference between these two. y1 is like this, y2 is like this. This is phase, this is phase. Difference is, here we express this phase in terms of linear displacement, x1 and x2. Here it is not like in terms of phase. The only difference, the corresponding amplitude of course. The difference between this and this is phase difference. There is one phase, another phase. Phase of one wave, phase of another wave. Difference is phase difference. If we do the same difference between these two, that is, this is always a phase difference inside this side of this angle. Phase difference equals this minus this. When you do the subtraction here, kx, there is cancel, omega t, omega cancel, plus and minus. So we get this remaining and k is constant and becomes x2 minus x1, it is delta x, final value. Notice delta x, here difference between x2 and x is called displacement, linear displacement. It is path difference, that is path difference, that is phase difference. Finally, we arrive at this equation. What is the equation? Y equals k into delta x. What is delta x? Path difference. What is phi? Phase difference. The relationship between these two is y equals k into delta x. What is k? Already know that k equals 2 pi by lambda. It is related to the Leo number. 2 pi by lambda. Remember this fundamental equation. We need to discuss about more about this in upcoming sessions. Now let us move on to our previous session. This is the point of interference. At this point of interference, the wave function changes at this point. It is a resultant wave. y1 is given, y2 is given. And what is the resultant wave at this point? It is derived. Let me recall that equation. This is the equation from the previous session. YR equals resultant wave equals AR into sine of kx minus omega t plus theta. What is AR? Resultant amplitude at this point of interference. What is theta? Is again the phase difference. These two have phase difference. After the interference, there is also phase difference. The resultant will be a phase difference of the resultant amplitude and this amplitude y1. That is a theta. And recall what is AR. It is also evaluated from the previous session. AR equals this. We can also write it as like this. It is in terms of square root, it is in terms of square like this. This is with respect to resultant amplitude. Now let us concentrate at this point. This is a point of interference. This point is visible when two waves are interfere each other. It is visible because the light is visible to our eye. And the resultant, this point is resultant intensity. So this has some intensity, this has some intensity. At this point, the intensity is not same. Either this or this, it is different. It is called as resultant intensity. That resultant intensity either increase or decrease. If there is an increase in intensity, it is known as constructive interference. Any decrease in intensity is called as destructive interference. Recall it from the previous session. So that is why on the screen, when the interference on the screen, when at the point of the screen interference takes place, you can see either a bright fringe or dark fringe. Bright fringe, the increase in intensity. Dark fringe, decrease in intensity. And this intensity of the light, as you know, basically it is related directly to the amplitude. Intensity of the wave, whether it may be light or any other wave, is directly proportional to its square of the amplitude. I am talking about the resultant intensity, therefore resultant amplitude, square of the resultant amplitude. So this is the equation, that is square, but here square in terms of square root, both are same. Square and square root like this. Either this or this. Intensity of the light is related to amplitude. Now, if that is the case, let us concentrate on the intensity of the light. So you have to write this equation in terms of intensity of the light. This I can take. Look at this equation and apply. Wherever I is there, write a square. Wherever I square is there, write I. I, here IR. A1, I1. A2, I2. A1, that is, if there is A1, root. If there is A, root of it. Cos phi remains same. Equation for the resultant intensity at this point. And this intensity of the light, intensity of this light is always varying between two limiting values. That is, intensity of the point is always varying between the two limiting points. One is highest value, other is the lowest value. The highest value you can call it as, what is that? IR maximum and IR minimum as the lowest value between these. So let us calculate what is the limiting values, highest value and lowest value from this equation. We can be able to assess what is the possible value of IR maximum and next IR minimum. So let us evaluate what is IR maximum value. In this equation, use a mathematical knowledge. This is IR is maximum, then cos pi value is plus 1, important, cos pi is plus 1. If cos pi is plus 1, it becomes I1 plus I2 plus 2, I1 plus I2 root under the root. So only that reduces this. So this is of the form A plus B whole square, where A is root. A plus B whole square, that is whole square, A1 plus A plus B. A is root of Y1, B is root of Y2. So this is of this form, plus is there. If the plus between these two, it is the maximum value. And similarly for resultant amplitude, this is maximum I. What would be the maximum amplitude? You can use the same amplitude. Yeah. When cos phi equals plus 1, that is reduced to this. This is of the form a1 plus a2 whole square under root a1 plus a2 whole square under root. For here maximum, root and 2 cancels a1 plus a2. That is a1 plus a2. Simply addition of these two amplitudes is the resultant amplitude. Here addition of this root of this whole square gives the resultant intensity of the light. And I said cos phi equals positive means what would be the possible value of phi, phase difference between the two waves. So not one value, it is a series of values. Maybe 0 or 2 pi, 4 pi, 6 pi. Cos 0 is 1 plus 1. Cos 2 pi is again plus 1. They are possible, possible values of phi. So we write in general form, it is phi equals n into 2 pi, where n is 0, 1, 2, 3 natural number like this. So general representation of phase difference is 2n pi, where n is series of values like this. So this is the phase difference. There is angular phase difference between y1 and y2. So this is the phase difference under constructive interference. So maximum value, maximum amplitude, maximum intensity. So this gives a constructive interference. There is a condition for the constructive interference. So equation tell us that maximum intensity or maximum amplitude, it is only in the case of constructive interference. Let us see some simple calculations. There may be a same amplitude or different amplitude. This equation, same amplitude. What is that? Same means a plus a 2a. If the amplitudes are same, the intensities are also same. I1 equals I2 equals I equals. That is same amplitude, same intensity. That is I. Root I means 2 root I. Whole square is there, it becomes 4I. What does it say that the resultant amplitude is increased by twice if they have same amplitude, and resultant intensity increased by 4 times if they have same amplitude, when two waves undergo constructive interference. This is geometrical representation. That is one wave, another wave, and this wave amplitude of this wave, let me write in terms of unit. It is 1 unit as well as 1 unit, same amplitude. There is a wave like this, and here they are getting coincided like this. For a constructive interference, the condition is this, and the phase difference of this or this or this, the waves are getting aligned like this. That is, crest and crest coincide, trough and trough coincide, and mix form a, what is that? The resultant amplitude like this. That is plus, what is that? 2a. They are equals to 2 units and 2 units. Resultant wave. There is a resultant amplitude, a resultant wave amplitude like this at the interference. That is for simple calculation again. This is for amplitude calculation. How do you calculate the intensity calculation? For IR equals 4I for same amplitude. 4I. What is I? I equals a square. Remember, I is a square. Same amplitude means a square. A is 1. That is A1 equals A2 equals 1. This whole square equals 4. Intensity increased by 4 times. Just imagine that if the amplitudes are same, if they undergo constructive interference, the intensity of the light, and the interference increase by 4 times. That gives a constructive interference or bright fringe. Why it becomes bright? Intensity increased by 4 times. Now the other case, here same amplitude, let me take different amplitudes. Here amplitude units I am taking as 2. Here amplitude as 1 unit. Here also these two waves undergo constructive interference because the phase difference in any one of these, that is the case. The alignment is that they are getting coincided. Crest wave, maybe bigger or small, coincided. Trough wave, coincided. Add up means after this constructive interference, A1 plus A2, that is 2 plus 1, the resultant wave amplitude is increased by 3 units. 2 plus 1 becomes 3 units as well as 3 units in this direction. AR is 3. And its intensity calculated in a similar way. For different intensities, we have this equation root I2. What is root I? That is root of I equals A. So it is A1. It is A1 plus A2. Root means A. A1 plus A2. What is A1? A1 plus A2. 2. A1 is 1. And 2 plus 1, 3. 3 square is 9. Intensity of the, what is that? Increased by 9 times. Because amplitude increased by like that. Any increase in resultant amplitude will increase the intensity very much higher. In this case, intensity of the light at this interference is increased by 9 times, even more brighter fringe we get. So this is a condition for the constructive interference. Why you get bright fringe? Let me continue in the next class regarding the destructive interference. We will talk about this and their corresponding equations. Thank you very much.